There are already a lot of Unreal Engine FPS tutorials online, but most focus on getting something working fast. Run around, shoot boxes, spawn some enemies, done. And if that's what you want, this series probably isn't for you. This series is different. We are building a scalable AAA style FPS framework using C++. A framework designed for single player, multiplayer, multiple players, NPC players, weapons, abilities, AI system, UI, network, state machine, and long-term expansion. Because professional FPS games are not built from random blueprints stitched together. They're built from scalable systems designed to grow over time, which involves server authoritative gameplay, modular architecture, data-driven systems, reusable gameplay frameworks, and that's exactly what we are planning on building in this series. Before we go any further, there's something important to understand. Building a professional FPS framework is not fast, and it's definitely not easy. This is not a make a game in one weekend project. This takes time, planning, iteration, debugging, refactoring, testing, and a long-term investment. Professional multiplayer FPS games are some of the most technically complex projects in game development. But if you want to understand how scalable FPS architecture is actually designed, then this series is for you. In this video, we're discussing the architecture design behind a professional FPS framework. Not just shooting mechanics, but the actual systems that allow a large FPS project to scale properly. In this video, we will cover the design concepts of core gameplay classes, player systems, weapon class structures, weapon data classes, character profiles, abilities, state machines, AI, UI, networking, and multiplayer architecture. Because in professional AAA game development, structure matters as much, if not more, than the gameplay. Most FPS projects don't fail because the shooting is bad. They fail because the architecture becomes impossible to maintain. Everything gets shoved into one character blueprint: movement, weapons, inventory, health, damage, UI, animations, abilities, and networking. At first it works, but eventually every new feature breaks something else. That's why professional games separate responsibilities into systems. The weapon handles firing, the inventory handles equipment, the health component handles damage, the UI reacts to gameplay events, the game mode controls the rules, and the networking layer controls authority and replication. The separation is what makes larger FPS projects possible. At the foundation are the core Unreal gameplay classes. Game mode controls spawning, match rules, objectives, and overall game flow. Game state controls replication match information like scores, timers, objectives, and team status. Player controller handles player input, camera ownership, menus, and communication with the HUD. Player state controls replicated players' data like kills, deaths, score, team, and selected character. And finally, game instance. This stores persistent data like settings, progression, online systems, match playing, and player profile information. These systems create the backbone of the framework before we even start building our gameplay mechanics. Instead of building everything into the player character, we'll create a shared base class. The player base will contain systems shared by both player controller characters and NPC controlled characters. From here, we create a player and an NPC player. The player handles camera systems, player input, first-person presentation, and local player functionality. NPC Player handles AI behavior, perception systems, and NPC-specific gameplay logic, but both still share health, damage, combat, inventory, animated systems, abilities, movement systems, and weapons. This keeps gameplay systems consistent across the entire game. A professional FPS framework also needs to support multiple character types and player styles. Not every character should feel the same. Different characters create different gameplay strategies, movement styles, combat roles, and team dynamics. So instead of hard-coding one player setup, we build around character profiles. Each profile will define things like health, movement speed, abilities, weapon access, animations, voice lines, visual style, and gameplay role. For example, an assault character may focus on aggressive mobility and fast combat. A heavy character should move slower but carry stronger weapons and more armor. A recon character might specialize in speed, scanning enemies, and precision weapons. A support character could focus on health, shields, or defensive equipment. This can all be driven by a character data class. This data class can control maximum health, movement settings, ability loadouts, starting weapons, character mesh, animation sets, UI colors, gameplay tags, and progression data. The framework handles the system. The character profile defines the identity. Now we move into one of the most important concepts in professional game architecture: component-based design. Instead of placing every system directly inside the player class, we split gameplay systems into reusable components. We have a health component, which handles health, healing, damage, death, and health events. A combat component, this handles aiming, firing requests, combat state, recoil, and reload logic. Inventory component, this handles equipped weapons, weapon switching, ammo storage, and item ownership. Team component handles the team logic and friendly fire checks. Hit reaction component, this handles impact reactions, camera shake, and damage feedback. The player owns the components, but the components own the gameplay systems. That keeps the framework modular, scalable, and easy to maintain long-term. Weapons also need their own scalable framework. We start with weapon-based class. This handles shared weapon functionality like equip state, ammo checks, reload logic, animations, effects, firing rules, recoil, and network support. From this, we then create specialized weapon types like bullet weapon class for rifles, pistols, SMGs, and sniper weapons. Projectile weapon class for rockets and launcher-based projectiles. Shotgun weapon for multi-pallet weapons. Melee weapon for knives, swords, fists, blunt weapons, and close-range combat. Explosive weapon class for explosive-based weapons like C4 charges, mines, remote explosives, timed explosives, and area damage weapons. From here, we can now derive more specialized explosive systems like Claymore weapon class for directional explosive traps, proximity mines, defense explosives, and area denial systems, and Thrown weapon class for throwable equipment and deployable combat items. From there, we can derive more specialized throwable weapons like Grenade weapon for fragmentation grenades, smoke grenades, flashbangs, incendiaries, and tactical explosives. Each weapon type controls its own firing or attack behavior, while still sharing the same base weapon framework. The player simply says, use the weapon. The weapon class handles the rest. This separation becomes critical in large FPS games with many weapon categories and combat systems. A professional FPS framework also needs a scalable way to manage information about each weapon. Instead of hard-coding weapon values directly inside the weapon class, we create dedicated weapon data classes. For example, a weapon data class, this stores configurable weapon details like weapon name, damage, fire rate, magazine size, reload speed, spread, recoil, range, projectile type, muzzle flash, sound effects, animations, crosshair behavior, weapon icons, and replication setting. Now, the weapon class only handles gameplay logic. The data asset handles weapon configuration. This means designers can create new weapon blueprints without rewriting gameplay systems. Assault rifle data, shotgun data, sniper rifle data, SMG data, rocket launcher data, grenade data, claymore data, all using the exact same weapon framework underneath the covers. Professional FPS games are heavily data-driven. Instead of constantly writing gameplay code, designers can create and balance content using editable data assets. C++ builds the systems, data assets build the gameplay content. The separation allows the framework to scale much faster during development. A professional FPS framework also needs clean finite state machine handling. As the game grows, the player can enter many different gameplay states: idle, moving, sprinting, aiming, firing, reloading, swapping weapons, using abilities, taking damage, downed, dead. The problem is that not every action should be allowed during every state. You should not fire while reloading. You should not sprint while aiming down sights. You should not reload while dead, and you should not swap weapons during certain abilities or animation. So instead, we use a structured state handling system. For example, player state enum. This enum can define major gameplay states like idle, combat, reloading, sprinting, ability, and dead. The state machine becomes the traffic controller for our gameplay systems. It decides what actions are allowed, what animations should play, what UI should display, and what game logic should be executed. AI also needs a scalable architecture. We use NPC Player, AI Player Controller, behavior trees, blackboards, and AI perception, and EQS for tactical positioning. The NPC player controls the physical character and the gameplay systems. The AI player controller controls decision-making and behavior. This separation keeps AI logic modular and easier to expand. The UI should react to gameplay events and not constantly search for data every frame. When health changes, update the health bar. When ammo changes, update the ammo counter. When the player takes damage, show a damage indicator. When the weapon changes, update the crosshair and weapon icon. This keeps the UI cleaner, faster, and easier to maintain. Even if your game starts as a single player, professional FPS frameworks should be designed with multiplayer in mind. The server validates gameplay actions. The server applies damage. The server controls score and match state. Clients can still play cosmetic events instantly for responsiveness, but authoritative gameplay belongs to the server. This structure helps prevent cheating and makes the game easier to scale long-term. Server authoritative gameplay is one of the biggest differences between a prototype FPS and a professional multiplayer shooter. So, just to recap, the complete framework looks like this. Core systems manage the rules. Players manage movement and ownership. NPC players manage AI-driven gameplay characters. Components manage gameplay systems. Weapons manage combat behavior. Weapon data classes manage weapon configuration. Character profiles manage playstyle and identity. Abilities manage advanced gameplay. State machines control what actions are allowed. AI player controllers manage enemy decisions. UI reacts to gameplay events. And networking keeps gameplay authoritative. This is the difference between building a single FPS tutorial project and building a professional game framework. I know this was a long, complex topic. However, understanding and planning how the framework is built goes a long way to developing professional level code. In the next video, we'll start building this framework step by step inside Unreal Engine. We'll create the core C++ project structure, base gameplay classes, and the foundation for a scalable FPS game. If you want to build your FPS project the professional way, this is where it starts. Let's build it properly.